CATV, or Community Antenna Television, wiring standards for home wiring are important for safety and performance. Let's examine these standards for both inside and outside the home. For inside the home wiring, refer to ANSI/SCTE 1, 2014, which is the standard for residential and premises wiring. This document provides guidelines for the proper installation and maintenance of cable wiring within a residential building. When it comes to the outside wiring, specifically the drop wire, ANSI/SCTE 3, 2014 is the standard for drop wire attached by clamping. This standard details the requirements for securely attaching the coaxial cable from the utility pole to the house. If fiber optic drop wire is being used, consult ANSI/SCTE 31, 2012, which is the standard for fiber optic drop wire attached by clamping. This provides guidance for fiber optic cable installations. Grounding is a critical aspect of CATV wiring. ANSI/SCTE 19, 2013 is the standard for antenna to grounding system performance. It outlines the requirements for effectively grounding the CATV system to protect against electrical surges and ensure safety. Additionally, in FBA 70, the National Electrical Code contains regulations for grounding and bonding, which are applicable to CATV systems as well. For the placement of the drop and attachment hardware, ANSI/SCTE 33, 2007 is the standard for aerial cable attachments for residential buildings. This standard provides guidelines for the proper placement and installation of hardware used to attach the cable to the building. Additional resources include the Society of Cable Telecommunications Engineers, or SCTE, the National Cable and Telecommunications Association, or NCTA, and Cable Labs. These organizations offer valuable information, training, and resources related to cable telecommunications. Specific standards to consider include CATV drop wire height. The minimum drop height is typically 10 feet above the ground for a single-story building and 15 feet for a multiple-story building. This ensures sufficient clearance for vehicles and pedestrians. When selecting attachment hardware, clamps or straps should be used to securely attach the drop wire to the building. These should be corrosion-resistant and designed for outdoor use. The drop wire should be grounded to the electrical grounding system of the building. This is typically achieved by connecting the cable shield to the grounding electrode system. As for coaxial cable type, RG6 or RG11 coaxial cable is typically used for CATV drops. RG6 is suitable for most residential applications, while RG11 is preferred for longer runs or areas with high interference. It is important to check with local building codes and regulations, as these may vary from the national standards. Always adhere to the most stringent requirements to ensure safety and compliance. Firstly, understanding ANSI/SCTE 1, 2014, the standard for residential and premises wiring, is essential. This standard covers various aspects of in-home CATV wiring, including cable types, connectors, and installation practices. Proper installation ensures signal quality and prevents interference. Secondly, ANSI/SCTE 3, 2014, the standard for drop wire attached by clamping, is crucial for external wiring. The drop wire is the cable that connects the home to the CATV network. Correct clamping techniques are vital to prevent damage and maintain signal integrity. Thirdly, ANSI/SCTE 31, 2012, the standard for fiber optic drop wire attached by clamping, addresses the specifics of fiber optic installations. Fiber optic cables offer higher bandwidth and improved performance, but require specialized handling and connectors. Fourthly, grounding is addressed by ANSI/SCTE 19, 2013, the standard for antenna to grounding system performance. Effective grounding protects equipment and personnel from electrical surges. The grounding system should be properly connected to the building's electrical ground. Fifthly, in FBA 70, the National Electrical Code provides comprehensive regulations for electrical safety, including grounding and bonding requirements applicable to CATV systems. Adhering to the NEC is essential for ensuring safe installations. Sixthly, ANSI/SCTE 33, 2007, the standard for aerial cable attachments for residential buildings, specifies how to securely attach cables to buildings. Proper attachment hardware and techniques prevent cable sag and potential hazards. The SCTE, NCTA, and Cable Labs offer a wealth of resources. These organizations provide training, certifications, and technical publications related to CATV and telecommunications. CATV drop wire height is an important safety consideration. Maintaining the correct height clearance prevents accidents and damage to the cable. Use appropriate clamps or straps to attach the drop wire. The hardware should be weather resistant and designed for the specific cable type. Always ground the drop wire to the building's electrical grounding system. This protects against lightning strikes and other electrical hazards. RG6 and RG11 coaxial cables are the common choices for CATV drops. RG6 is suitable for shorter distances, while RG11 offers better signal quality over longer runs. Remember to always consult local building codes and regulations. Local requirements may differ from national standards. Safety should always be the top priority when working with electrical and CATV systems. If you are unsure about any aspect of the installation, consult a qualified professional. Grounding the CATV system is crucial for several reasons. It provides a path for stray electrical currents to safely return to the source, preventing them from causing damage to equipment or posing a shock hazard to people. A properly grounded system also helps to reduce electrical noise and interference, which can improve signal quality. The grounding electrode system should consist of a grounding electrode, such as a ground rod or metallic water pipe, that is connected to the building's electrical service panel. The CATV system should be bonded to this grounding electrode system using a grounding conductor. The grounding conductor should be sized appropriately for the system and should be installed in a way that minimizes the length of the ground path. The connection between the grounding conductor and the grounding electrode should be made using a listed connector. In addition to grounding the CATV system at the service entrance, it may also be necessary to ground it at other locations throughout the building, such as at the point where the cable enters the building or at the location of any amplifiers or other equipment. The National Electrical Code, or NEC, provides detailed requirements for grounding and bonding electrical systems, including CATV systems. It is important to consult the NEC and any applicable local codes to ensure that the CATV system is properly grounded. The NEC specifies the minimum size of the grounding conductor, the type of grounding electrode that can be used, and the methods for connecting the grounding conductor to the grounding electrode. The NEC also requires that all metallic parts of the CATV system be bonded together to create a low-impedance ground path. This bonding helps to prevent voltage differences between different parts of the system, which can cause electrical noise and interference. When installing a CATV system, it is important to use high-quality components that are designed for the application. The cable should be properly shielded to prevent interference, and the connectors should be securely attached to the cable. The cable should also be installed in a way that protects it from physical damage. When running the cable through walls or ceilings, it should be protected by conduit or other means. The cable should also be supported at regular intervals to prevent it from sagging or becoming damaged. The installation of CATV systems is often subject to local built-in codes and regulations. These codes may specify the type of cable that can be used, the methods for grounding the system, and the requirements for installing the cable. It is important to consult with a local building department to determine the applicable codes and regulations before beginning any installation work. The Society of Cable Telecommunications Engineers, or SCTE, is a professional organization that provides training and certification for CATV technicians. The SCTE offers a variety of courses and certifications that can help technicians to develop the skills and knowledge necessary to install and maintain CATV systems. The National Cable and Telecommunications Association, or NCTA, is a trade association that represents the cable industry. The NCTA provides information and resources for cable companies and consumers. The NCTA also advocates for policies that promote the growth and development of the cable industry. Cable Labs is a research and development consortium that focuses on developing new technologies for the cable industry. Cable Labs conducts research on a variety of topics, including broadband internet access, video delivery, and wireless communications. CATV systems have evolved significantly over the years. In the early days of CATV, systems were used primarily to provide television service to homes in areas where over-the-air reception was poor. Today, CATV systems are used to provide a wide range of services, including television, internet access, and telephone service. The technology used in CATV systems has also evolved significantly. Early CATV systems used analog signals to transmit television signals. Today, most CATV systems use digital signals, which provide better picture quality and allow for more channels to be transmitted. The internet has also had a major impact on the CATV industry. Many cable companies now offer broadband internet access over their CATV systems. This has allowed cable companies to compete with telephone companies and other internet service providers. The future of CATV is likely to be shaped by a number of factors, including the continued growth of the internet, the increasing demand for high-definition video, and the development of new technologies. Cable companies will need to continue to innovate in order to remain competitive in the rapidly evolving telecommunications market. The key to a successful CATV installation lies in adhering to established standards, employing quality components, and ensuring proper grounding. Always prioritize safety and consult with professionals when needed. Remember that RG6 cable is typically used for shorter runs within the home, connecting devices to wall outlets. RG11 cable, being thicker, is preferred for the main drop from the street to the house and for longer runs inside to minimize signal loss. Proper grounding involves connecting the cable shield to the main electrical ground, typically at the point where the cable enters the building. This is crucial for safety and signal integrity. Before starting any CATV wiring project, carefully review local building codes. These codes may have specific requirements regarding cable type, grounding, and installation methods. When running cables, avoid sharp bends, which can damage the cable and degrade signal quality. Use cable ties to keep cables organized and prevent them from becoming tangled. When connecting cables to devices, ensure that the connectors are properly tightened. Loose connectors can cause signal loss and interference. Periodically inspect the CATV wiring system for any signs of damage, such as cracked or frayed cables. Replace any damaged components promptly. CATV systems are susceptible to interference from other electronic devices. To minimize interference, keep CATV cables away from power cords and other sources of electromagnetic radiation. When installing a new CATV system, it is important to test the signal strength at various points throughout the building. This will help to identify any areas where the signal is weak or degraded. Signal amplifiers can be used to boost the signal strength in areas where it is weak. However, it is important to use amplifiers that are designed for CATV applications. Using the wrong type of amplifier can actually degrade the signal quality. CATV systems should be inspected and maintained on a regular basis to ensure that they are operating properly. This includes checking the cables for damage, tightening the connectors, and testing the signal strength. Proper maintenance can help to prevent problems and extend the life of the system. Understanding the basic principles of electricity is helpful when working with CATV systems. This includes knowing the difference between voltage, current, and resistance. Voltage is the electrical potential difference between 2 points. Current is the flow of electrical charge. Resistance is the opposition to the flow of electrical charge. The relationship between voltage, current, and resistance is described by Ohm's law, which states that voltage is equal to current times resistance. Electrical safety is always important. Always turn off the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment. If you are not comfortable working with electricity, hire a qualified electrician. When working with CATV systems, it is important to be aware of the potential for electromagnetic interference. Electromagnetic interference, or EMI, is unwanted electrical energy that can disrupt the operation of electronic devices. EMI can be caused by a variety of sources, including power lines, radio transmitters, and electronic equipment. To minimize EMI, CATV cables should be shielded and grounded. Shielding involves wrapping the cable with a conductive material that blocks electromagnetic radiation. Grounding involves connecting the cable to the earth, which provides a path for unwanted electrical energy to flow to ground. In addition to shielding and grounding, other techniques can be used to minimize EMI. These include using ferrite beads to filter out unwanted frequencies, keeping cables away from sources of EMI, and using shielded connectors. CATV systems are constantly evolving. New technologies are being developed all the time to improve the performance and capabilities of these systems. Stay up to date on the latest developments in CATV technology to ensure that you are using the best possible system for your needs.